Normalization is the process of eliminating redundancy from a database. This reduces data anomalies, as well as making OLTP updates more efficient by allowing higher concurrency. So by data anomaly, let's look at it this way. It's not normal to wear 2 wristwatches. And it's also not normal to have an attribute value repeated throughout a database. You may think that if you wear 10 different watches, that your chances of knowing the time improve. But in fact, the opposite is true. And when you need to determine the time, you find yourself confused. So let's talk about first normal form. First normal form has 2 basic rules. Number 1, no repeating groups. Number 2, every row should be unique. We can easily achieve the second one by setting a primary key. But what's this first rule all about? No repeating groups. A repeating group is an array of data. In the past, database systems allowed a single field to contain a complex array of data. However, databases like SQL Server don't allow this. You can only put one value inside of a field. So technically speaking, you can't violate that aspect of first normal form. But let's take a look at this. So I'm going to create a supplier table. I'm setting supplier ID to be the primary key, and so now I've complied with the rule that every row will be unique. Notice I've left a products field here. Let's see how I'm planning to use that. Let's open the supplier table that I just created and add a supplier. Now notice what I've done here. I've added a supplier, Nuts and Bolts Incorporated, and under products I've listed nut, bolt, and screw separated by a comma. So I've created a fake array. I have not created an array that SQL Server is structurally aware of, and I would have to sort through this in my application on my own. Let's try another example. So here's another design for my suppliers table. This time I haven't tried to fake an array inside of one field, but instead I've added a field for each individual product. This is also considered a violation of first normal form. It's pretty easy to fix both of these. A simple way to solve this is to put products in their own table, and then by using my supplier ID, I can identify in that table which product belongs to which supplier. And now for every new product, I get a new row. A table that is in second normal form must be in first normal form. And then the main rule of 2NF is that there are no partial key dependencies. This means that whatever the multi-column key is of the table, any other values would have to be completely dependent upon all columns in that key. Let's take, for example, this table, products. Every product has an ID, a name, a store location, and a price. Let's see how I might fill this table in. Price is dependent upon product ID and product name, but not store. It's the same price no matter what store we go to. So here we've broken it down a little further, and you can see in my new table design that in the products table, price is dependent upon product. And down in the stores table, you can see that the product depends upon the store. Some things might look wrong about these tables to you if you've worked in OLTP transactional environments. For instance, in the stores table, the product name column. Obviously, that would cause the product name to be repeated in many rows. This is acceptable under the rules of second normal form. The attributes must be dependent upon the key, and in this case, product is dependent upon store. But the attributes don't have to depend only on the key. So product name in this case does depend on store, but it doesn't only depend on store for its existence. This demonstrates the difference between second normal form and third normal form. Second normal form, attributes must be dependent upon the key, but in third normal form, attributes must be dependent solely upon the key. Also, when you compare OLTP to OLAP, OLAP only normalizes up to second normal form. So every row in an OLAP table must be unique, and they must be compliant with first normal form, which is easy enough. But they also must comply with second normal form, so attributes must be dependent upon the key. But you are allowed to do things like we see in this example. So product name could be repeated. This is very helpful in an OLAP table situation, and we'll see that later. So third normal form essentially removes transitive dependencies from your table. And that's where things that don't belong together sort of need to be broken apart. And I'm sure, as you can understand, products and stores really should be broken apart because they're very separate things. So here you can see I've taken the product name field out of the stores table. I've created an inventory table where I can map stores to products. And in that table, each row would contain a unique combination of store ID and product ID.